Water is essential to life, but the wastewater we produce have a serious environmental challenge. To truly understand its impact, let's zoom in and explore wastewater at the molecular level. As we look closer, we see molecules of pollutants like nitrates, phosphates, and heavy metals suspended in water. These contaminants disrupt ecosystem, harming aquatic life and even affecting human health. Understanding this molecular interaction allows us to create more effective wastewater treatments. By breaking down this pollutant at the source, we can protect our water system and promote a healthier environment.
So, how can we detect the impurities in the water? Well, there's an application called spectroscopy. What we will do is expose the impure water with UV.
The impurities in water can be detected by measuring the absorbance of UV light at specific wavelengths. Impurities absorb UV light differently compared to pure water, which can be seen in this diagram. And as you can see, impurities such as CO2 and ozone layer will break down after absorbing the UV light, but for the water molecules, it does not do anything. This creates a distinct peaks in the absorbance spectrum. As proof, this diagram is from a research conducted to see whether it's valid or not through the peaks. By comparing the peaks of those of known substances and using calibration curves, the presence and concentration of impurities can be determined.
Now, how can the water be treated? We can apply a photobioreactor to treat the water, and this can be done by finding a spot in the river that contains the highest concentration of sunlight and place the photobioreactor there.
And how it works is that the algae in the photobioreactor in that spot will cultivate and grow and use the light for photosynthesis, which will then absorb contaminants from the air. And as they grow, they convert harmful substances into a less toxic byproducts through biology processes. And the treated water or air is then separated from the biomass, which can further be processed and removed. This approach will effectively reduce the pollutant levels through a combination of biology activity and light energy. Hence, it's why it's called the photobiochemistry.
The reuse of wastewater is a common practice all around the world to help meet the global water demand. Wastewater may originate from industries or domestic housing, and after treatment, it is mostly reused for irrigation. Untreated wastewater contains organic components and pathogens that pose a deadly risk to humans and the environment. Long-term effects of constant use of mistreated wastewater can cause typhoid, dysentery, diarrhea, vomiting, and malabsorption. For assessment of wastewater, the Comprehensive Pollution Index (CPI) is used. Now let's dive in. A spectroscopy is useful for the detection of impurities. An algae is used for bioremediation. Bioremediation involves the absorption of harmful substances, converting it to less toxic produce. This has positive impacts on both humans and the environment. First, the removal of harmful substances makes it safer for the reuse of wastewater. This will greatly reduce the number of sicknesses, resulting in overall improvement of human health. High levels of pathogens and organic compounds have been detected in Seine River waters. This was due to prolonged leaking of wastewater and rainwater runoff from streets. The contamination in the body of water has caused health issues in the athletes that participated in the 2024 Paris Olympics. Symptoms include skin infections, airway irritations, and stomach infections.
So, from the molecular level, we can see that photobiochemistry is literally cleaning up pollutants in wastewater. And when you zoom out, it's not just the water. Ecosystems are healthier, air quality improves, and we are protecting our planet. All thanks to harnessing light and biology. It's amazing how small changes at the molecular level will make such a big difference. Thank you.